This is a friction question on Newton's third law, and it can be a pretty difficult question if you are seeing this for the first time. So we will go through this together. It will be much easier once you realize the mechanics of how wheels turn and what drives a car forward. So the answer to this question is actually B, and we will derive this direction together. So first up, there are two types of cars, front wheel driven cars and rear wheel driven cars. This just means that the engine drives the wheel, and if it's a front powered wheel or front wheel driven car, the engine drives the forward wheel only. The backwards wheel is free to just roll along and because the front wheels are the one that is being powered. So a front powered wheel is driven by the engine. You might want to use a coin or any bottle cap to try this out. For a car to move forward, the front wheel must be driven in a clockwise direction. You must rotate the front wheel clockwise, then the car will be able to move forward. Okay, so just try it out and you will see that it must turn clockwise, the wheel must turn clockwise. And therefore, this is what the engine does. The engine rotates the front wheel in a clockwise direction. Now, second point, when you are rotating the front wheel, I want you to look at the bottom of the wheel because that's the part of the wheel that touches the ground. So this bottom part of the wheel, actually, when it rotates clockwise, it pushes backwards on the floor by virtue of its rotation, its clockwise rotation. When it rotates clockwise at the bottom of the wheel where it touches the ground, the wheel is actually moving backwards. It's pushing backwards on the floor. So therefore, this results in a forward force acting on the wheel itself. This is because of Newton's third law. The wheel pushes on the ground backwards, the ground pushes on the wheel forward. And this is the reason why the car can move forward when the wheel rotates clockwise. And sometimes we call this traction also. Now let's look at the back wheel. The back wheel gets so-called drag along. It's not powered by the engine, so it gets dragged forward, and when something gets dragged forward, frictional force opposes it. It will be backwards. Okay, so by Newton's third law, when the frictional force on the wheel is backwards, this friction actually slows down the car, and this is how the frictional force on both of the wheels are different.